Abu Musa Jabir ibn Hayyan, Muslim alchemist. Abu Musa Jabir ibn Hayyan, born 721, Tus, Iran, died 815, Al-Kufa, Iraq, Muslim alchemist known as the father of Arabic chemistry. He systematized a quantitative analysis of substances and was the inspiration for Geber, a Latin alchemist who developed an important corpuscular theory of matter. According to tradition, Jabir was an alchemist and possibly an apothecary or physician who lived mostly in the 8th century. Some sources claim that he was a student of the 6th Shiite Imam, Jafar ibn Muhammad. As the historian Paul Krauss showed in the 1940s, however, the almost 3,000 works attributed to this Jabir cannot possibly have been written by one man. They contain too much disparity, in both style and content. Additionally, the Jabirian corpus displays numerous indications linking it to the Ismailite movement of Fatimid times. Most of the works attributed to Jabir were probably written in the 9th and 10th centuries. Perhaps the most original aspect of the Jabirian corpus is a type of arithmology, numerology, referred to as the method of the balance, mizan. In essence, this consisted of determining the quantity of the 4 natures, hot, cold, wet, and dry, in a substance by means of its name. Each letter of the Arabic alphabet was given a numerical value, and depending on the order of the letters, they were applied to the different natures. The Jabirian texts also argue that all things contain a hidden, batin reality as well as the manifest, zahir, one arrived at in the way described. The hidden natures were thought to fall into the proportionality 1, 3, 5, 8, which always added up to 17 or a multiple of 17. Despite the more fanciful aspects of the Jabirian method of the balance, the corpus attributed to Jabir contains much of value in the realm of chemical technology. The Jabirian corpus was an important vector for the long-lived theory that the known metals are composed of sulfur and mercury, and it provides metallurgical evidence to support this claim. The works give detailed descriptions for alloying, purifying, and testing the metals, in which considerable use is made of fractional distillation in order to isolate the different natures. The chemistry of sal ammoniac, ammonium chloride, forms a particular focus for the Jabirian writings. This substance was of interest primarily for its ability to combine with most of the metals known in the Middle Ages, rendering the metals soluble and volatile in varying degrees. Since volatility was viewed as a sign of a pneumatic or spiritual nature, the Jabirian alchemists viewed sal ammoniac as a particular key of the art. Only a tiny fraction of the Jabirian works made their way into the medieval West. Jabir's 70 books was translated into Latin as the Liber de Septuaginta by Gerard of Cremona in the 12th century. A mutilated version of this work was known to the Latin pseudepigrapher who called himself Geber, transliterated from the Arabic Jabir, who wrote the Summa Perfectionis Magisteri, the Sum of Perfection or the Perfect Magistery, possibly the most famous alchemical book of the Middle Ages. Probably composed in the late 13th century by a Franciscan monk known as Paul of Taranto, the Summa contains no trace of Jabir's arithmological method of the balance. The Summa is sometimes accompanied by 4 other works also attributed to Geber: De Investigation Perfectionis, De Invention Veritas, De Fornacibus Construendis, and Testamentum. Despite this attribution, these works are all substantially later than the Summa and could not have the same author. Like his Arabic models, the author of the Summa was unaware of 2 key developments in medieval technology: the distillation of ethyl alcohol and the fabrication of the mineral acids, although mineral acids do appear in the later works attributed to Geber. The Summa contains the first clear statement of the mercury alone theory, according to which quicksilver, mercury, is the pure substance of the metals, and sulfur is primarily a corruptor. In an attempt to imitate the operations of nature itself, Geber advised other alchemists to rely on quicksilver and its compounds for transmutational agents and to eschew organic materials such as blood, hair, and eggs. A second innovation of the Summa lies in its groundbreaking theory of three orders of medicines. According to this theory, which owes something to vague comments found in Jabir's Liber de Septuaginta, transmutative agents occur in a threefold order of increasing effectiveness. A medicine of the first or second order leads to superficial and temporary change in the base metals, whereas a medicine of the third order produces genuine and permanent silver or gold. The Summa gives a corpuscular explanation to the varied perfection of the medicines, arguing that a medicine's perfection increases as the corpuscles from which it is made decrease in size. This corpuscular theory of matter is used by Geber to explain a host of processes, including sublimation, distillation, calcination, cupellation, cementation, and the production of minerals within mines. Geber's corpuscular theory was to have a major impact in the history of science.